Having understood the biodiversity and habitat conservation model, we now move to the carbon sequestration model. In the biodiversity and habitat model, it was just a straightforward indirect mapping and assigning of values onto a raster. But for the carbon sequestration model, now we are able to generate a biophysical indicator through various processes so that we can be able now to assign those processes that have been directly mapped with a value. So what is important about the carbon sequestration model? It is important to know that current and predicted patterns of global climate change are a major concern in many areas of socioeconomic activities. This is things like agriculture, forestry, rangelands, and consequently, they are a major threat for biodiversity and ecosystem functions. In carbon sequestration, the natural process by which atmospheric carbon dioxide is taken up by the trees, grasses, and other plants through photosynthesis and stored as carbon in various terrestrial pools, including above-ground biomass. This is according to USDA 2020. Then we also have the below-ground biomass, which is the soil complexes. And these are some of the carbon pools or terrestrial pools that we'll be using to calculate the carbon sequestered and the value that comes as a result of this sequestration. So what are the ecosystem service indicators for quantification? 1, we have the model considers the total amount of carbon dioxide sequestered, that is a biophysical assessment. And the key indicator for the biophysical assessment is the carbon dioxide. And how do we generate this carbon dioxide that is sequestered? It is by looking at the biomass and the soil organic carbon. There are quite a number of data sets, Earth observation data sets for biomass generated annually. There are quite a number of soil organic carbon data sets that are generated annually. And most of these data sets, these global data sets, can be used to calculate the biomass. Where possible, for those that can be able to undertake satellite imagery, high resolution, they can be able to also generate their own biomass and soil organic carbon. But for those that cannot, it is advisable to use available global data sets to be able to undertake this biophysical assessment and do the calculations. The economic assessment is basically employing the direct market price. That is the direct market price for carbon. There are the social carbon trading pools where one can be able to know what is the value of carbon in any prevailing year of socioeconomic valuation. So let us have a look at the carbon sequestration model. It also has captured 3 significant ecosystems, the forest, the wetland, and the rangelands, where, as demonstrated there, you can be able to see the data inputs and the various data requirements for you to be able to run this model. In the model data requirement, the first data set that you need is the land use, land cover raster. In that case, it means for that particular year of assessment, you need to be able to carry out a land cover so that you can establish the correct area of the forest and bring in that land cover for use in the valuation. The next product you need is the above ground biomass, which is normally in tons per hectare. And the next thing is the soil organic carbon, that is also in tons per hectare. The numeric values that you also need is on-site carbon emissions. It's an optional input if you have the data. If you don't have the data, you can leave it. And then we have the social unit cost of carbon dioxide, applicable currency per ton. Could be US dollars, could be any other currency that you're using. But most of the ones that I've seen, normally the social unit of carbon dioxide is in US dollars, unless you convert it to your local currency. So let us now move to our model demonstration. Open your Colward tool with the start button and be able to target the carbon sequestration model. Open it so that we can be able to know what data sets we are loading, run the model, and see what happens. So we have our carbon sequestration model there. You should be able to open it and get a window like this, written carbon sequestration with forest, wetland, rangelands, and the summation tab. So since we started off with the biodiversity and habitat conservation for forests, we'll also do this for forests. for the purposes of summation on our last day to be able to visualize what is the value that we are getting for this particular ecosystem. So our first input raster data sets there is the forest land use and the biomass data. The second one is the forest land use and the SOC. Remember we said that we are using the carbon pool, the SOC and the biomass. The biomass, the above ground biomass considered here behind the model is also able to calculate the below ground biomass. And then we have the on-site emissions. We said that if you have data, you should be able to input. If you don't have, we just input a value of 0, and then we'll be able to get the net carbon stock. And then once we put the social unit cost of carbon, then we're able to get the valued net carbon stock. So we input our data there. Go to the file where you have stored your data sets. The training data, that is where I've stored my data sets. The first one there is the carbon sequestration model, the Kariba data. Remember we said we are dealing with the Kariba landscapes to be able to see what we can get. So we will load the above ground biomass and the LULUCF. Make sure you load these two data sets at the same time. Then you should be able to visualize there and see the carbon sequestration LULUCF land use land cover for forest of Kariba and the above ground biomass for Kariba. So someone may ask, where will you get the data sets for the above ground biomass for Kariba? This data set, the biomass data is generated, and you can be able to find other observation data online. Links to where you can be able to find this data are being provided for in the guide. The land use land cover forest for Kariba, in case you are working with your own landscape, you must be in a position to do a very good land cover classification that you can use. There are data repositories of land use land cover classes online in various websites, but they may not be as accurate as you'd want them to be for this particular exercise. Then you move to the next browser where you have your data input. Here, the carbon sequestration folder. You now load the SOC file and the land use land cover forest for Kariba. So you have the data sets there. You can see the land use land use land cover forest for Kariba and the soil organic carbon for Kariba. The SOC is also as an other observation data that is already prepared, and you can find it online. The link to where you can be able to find such data sets have been provided for in the guide that we have given. Like I said in the onset carbon emissions, if you don't have values that you can use for this particular exercise, you can have a value of 0. Then you browse and highlight the folder where you'd like your files to be saved. For my case, I'm still using the training data folder where I have an output data. All the files will be able to go there. I select it. And then the social unit for carbon, the last time I checked was around 1,000, but always check the prevailing market price of the social unit of carbon so that you can be able to have an accurate figure to use there. You also select again where you'd want your output folder, your output file to go so that you can be able to visualize it. So I'll still select the same file. And then now, since I've input all the data sets, I can be able to run the model. You can repeat the same for wetland if you have wetland data, if you have rangeland data, so that you can be able to visualize. So we run the model. And the model has successfully finished running. So we move now to QGIS to be able to visualize our product and see what we have. So we now visualize our carbon sequestration model. We go to layer, add vector layer. We go to the folder where we directed the output to be stored. We open. And there we have our carbon sequestration raster layer. You can see the values there. You can be able to just go in and categorize the classes, because since this is a direct mapping process, you'll have different values for different pixels depending on the biomass data that was used in the input. And that is it for the carbon sequestration model. we end here as we move on to the cultural, recreation, and education model. Thank you.